So it's a great pleasure for me to be here, and also a great honor too. So let me introduce myself quickly. So my name is Arnaud Tournier. I'm sometimes a speaker, like at Java8 this year, in which I presented this same presentation, but version 1. This one is version 2, so it might be better. But also much shorter, because it was 2 hours in Java8, and now it's only 40 minutes, so I try to make the best of the time we have. So I do trainings and so on, so not important. So before we begin, this presentation is online, so if you want to see it afterwards, you can. This presentation is about a project I call Angular2 Boot, which is a way to program Angular2 applications directly with Java8 through the help of the GUID compiler. And it started as an experiment, but eventually it became the best RIA framework in the world. No, I'm just kidding. No, I'm not kidding. You will see. If I would have chosen a more technical title, maybe it would have been integrating Angular2 and GUID 2.8. Like what are the problems, what solutions you can find. But first, the question you can ask yourself is why would I want to do Angular2 applications with Java8? Well, I was thinking about that, and as you know, Angular2 has 2 paradigms that we don't have in GUID. Like it's data binding, which is very awesome when you want to be productive. And also dependency injection. I mean, you can use Dagger2 and Gin in GUID, but Angular has its own dependency injection mechanism. I want to use to have strong typing when I code, so I can refactor my code easily, have powerful IDE tools, and so on. The point is to be, of course, more productive, and I want to be in phase with the future. Meaning, okay, we let the widgets behind us, and what can we do after that? And maybe I want to also evolve an existing application, an existing GUID applications. I want to benefit from new modern paradigms, like data binding mainly. The problem is that Angular2 has if you go to the official website, it supports TypeScript, JavaScript, and Dart, but not Java officially. So I thought maybe let's try to remedy that. Let's try something. So I tried to build a recipe. As I said, it was a kind of an experiment at the beginning. So first of all, let's try to see what ingredients we can put in this recipe to be able to achieve programming Angular2 applications in Java8. So of course we need Angular2, and we'll use the JavaScript runtime of Angular2. As you know, Angular2 is written in TypeScript, but at the end it's compiled into JavaScript. Why Angular2? Because it's a rewrite of Angular1 with a lot of improvements and a modern architecture, which is simple and effective. So that's a good one to use. When you think about putting Java in the browser, then you will think about GUID, of course. And we'll use GUID 2.8 with Java8 support, JS interop, which we talk about today a lot, super dev mode, and also a very good aspect of GUID is the compilation, the compiler, which produces very small JavaScript files, and which is very efficient, makes a lot of optimizations. We'll use also a lot of Java annotation processing API. So today, as you saw, many people talk about this Java annotation processing API. I remember I gave a talk last year in the GUIDCon conference about this API, so if you want to find information on how to use it, you can go back to the talk I gave last year. But basically it allows you to do what GUID deferred binding was allowing you to do, which means generating code during the compilation by analyzing the code that has been manually written by the developer. And as a backend, I wanted to change from Jetty and Java8, so I tried the Spring Boot because it's simple to use. But you cannot, with Angular2 boot, the main purpose is the client side, the front side, so the backend is not so important, it's just a matter of serving files and providing web services. So let's dig a bit in the few components I said I put in the recipe. So Angular, the first version was released in 2009, and as far as I remember, it's the first framework who provided data binding in the browser, so it has a really, really big success. And when the idea of making a version 2 came into the mind of the people in the Angular team, they benefited from this big return of experience they had, because like Angular, I don't know how many applications were deployed with Angular 1, but so they had this big return of experience, and they decided to rewrite it from scratch, which led to a better and simpler architecture, as you will see. There are 3 points you need to know when you want to at least introduce yourself to Angular 2. Those are the core concepts of Angular 2. So first of all, there are components. There is this dependency injection mechanism, and the data binding and the change detection mechanism. About the components, there will be the most basic building blocks in your application. And basically you can see it as a Java class, because we will be doing Java, so let's talk about classes, which will embed both a view, which will be an HTML template, and a model, which will be your fields and your methods in your Java class. And those two aspects, the view and the model, will communicate through data binding, which is provided by Angular. Components, they will be responsible for part of the DOM tree, and they will assemble themselves as a tree also. So the component tree will span over the DOM tree. It's a little bit like the widgets, in fact, that we know in GUID. The only thing is that regarding Angular, there is clearly well-defined ways to make communication happen between components. So they have inputs and outputs, and that's how you need to make them communicate. So it's on this side, it's a bit more clear than in GUID, where you can do whatever you want as soon as you have a reference to a widget instance. So for example, when you have a running Angular 2 application, you will have this kind of tree of component, like this is the application component, which controls, if I remember well, in this example, so it was an application to consult and rate talks during a conference. So this is the top root module component, sorry. There is a filter component which will present to the user a search field, which will filter the talks, which are displayed inside the talks component, and each talk will be displayed in its own talk component. So you get a kind of a tree, but we are used to in GUID. The dependency injection mechanism in Angular is used to share services and services between components. The thing is that the services or components, because Angular does it for you and manages the life cycle of your components. Yeah, that's it. And about the data binding in Angular2, it's taken care of kind of automatically, but I think there is something interesting in that because they use Zone.js, which originated from the Dart team. And Zone.js is a kind of an interesting concept for a Java developer, because it really, if you want to define it, you would say it's kind of an asynchronous thread local storage, meaning it preserves the context of execution across asynchronous codes. So if you're curious, you can go there and inspire yourself. In Angular2 boot, we'll use, as I said, Git, but we try to use very small parts of it. I mean, only the core of it. We just use the compiler of Git. Of course, we use JSInterrupt a lot because we have to talk with Angular. But the thing is that we don't use no widgets when we do an Angular2 to boot application. Of course, unless you will see, it will be possible to integrate Angular components inside your legacy Git application, or you can do the other way around. But as soon as you make a full Angular2 application, you don't need to have widgets, and so you don't need to have the user module in your applications module. As I said, we use a lot the GSR269, so pluggable annotation processing API, which is standard of Java. The idea is to use it to generate boilerplate code so that the developer doesn't have to do it when it comes to making the communication happen between Angular and Git. So this is the perfect tool to generate boilerplate codes. The idea is that you write your processors and they get called by the Java compiler, and then you can analyze the code base and generate source files accordingly. What's cool with GSR269 is that the code that is generated is visible, so you can put breakpoints in it, for example. You can reference the generated code in your own code. And since the generation happens at compile time, you get no overhead at runtime by doing this. It's not like manipulating bytecode at runtime. But most importantly, since it doesn't depend on bytecode, then it's Git compatible. And just one more thing which is interesting with the GSR269 is that you can output errors during your processing, and if you do that, they will become standard errors of the Java compiler. So if you output an error and you compile your file with Java8, for example, then you will get error at line this and this and this and your message. And this is leveraged by the IDEs. At least Eclipse, I guess IntelliJ does that too, but I didn't try it. And for example, during the generation of your code, if your algorithm found that so in this case, didn't find an ID field in the book class, you can generate an error. You can say to the Java compiler, the error is because of this element in the source file. So then Eclipse will be able to underline the element which provoked the error, and will give a text, the text that you gave as the error message. So it works with the errors and also the warnings. So it's a cool way to provide tips and hints to to the developer. Because as soon as something is not good from your perspective in the processor, then you can generate a warning, say where the warning happens, and then the user gets feedback, and it's very quick. So that's very useful. And in fact, that's how it is done the JPA validation, I think. I mean, in Eclipse, when you can use, I don't remember the library name, but if you don't put the right annotation on your JPA entities, you will get warnings, and they are generated through this API also. So now that we have the ingredients and we see what we will put in Angular 2 boot, let's see how it works. So first, how it works and what were the problems to solve. So first of all, the problem is to make JavaScript and your Java code communicate, and this is really easy with JS interrupt. Because you will have from your Java code to call sometimes Angular, but also Angular has to instantiate your components. So it needs to be both ways. Then Angular needs, mainly for its dependency injection mechanism, it needs to have kind of metadata about your components. And so that it's able to do dependency injection, routing, resolving inputs and outputs of your components and so on. And what they do is they have a JavaScript API, but they have also, I mean, mainstream Angular 2 application use TypeScript, and to provide the metadata they will use TypeScript decorators, which are used to alter component constructors at runtime. So it happens at runtime in the JS world with the decorators. But in Java, we have the annotations, which can basically seen as this kind of equivalent with the ECMAScript 7 decorators. The only difference is that they are processed at compile time with the JS8 269. But we'll be able to put annotations on our Java class, and then we'll be able to provide Angular with the runtime type information, this RTTI, to Angular. And how do we do that? So it's first, we use the JS269 to analyze your components, your annotations, and so on. Then the JS269 generator will generate a class which will use JS interrupt to provide Angular 2 with your components metadata through the JS API of Angular 2. So it doesn't use the decorators, it uses the JavaScript API of Angular 2. Then it will kind of transform the constructor that is built by the GUID compiler until it will patch it by adding the required metadata so that Angular is able to recognize and to have information about your components. So with this, we just look at a typical Angular 2 component in TypeScript. So this is the hero detail component. It shows the details of an hero instance. It has an input, which is the heroes it must display, and it has an output, which basically output events to the parent component, which can grab it and do whatever it wants. And what else here is the syntax in TypeScript to get this hero service instance injected by Angular automatically. And this is an example of a lifecycle hook that you can implement in your component if you want to do processing at certain stage of the life cycle of your components. And if you look at the what we could have in Java when you want to write a component, it's, well, okay, there's the scroll bar, so we know Java is a bit more verbose than JavaScript, but it looks kind of the same. So this class, there's more typing here, because I can declare I need to implement this lifecycle interface, then which I need to implement this method. So that's more typed. And I receive the hero service instance by using the same way. I'm declaring that I want in my constructor to receive the service. And I have the same input and output. So you see, it's looking kind of the same. And the idea, in fact, is to be able to have a consistent syntax between Angular TypeScript, Angular Dart, and Angular Java. So that it can be, for example, easy to read the documentation of the TypeScript version. You can use it in your Java for your Java code. So, how does it work? The big picture is like this. So first is you do the compilation. The compilation, how does it work? Then you have your Java source files that you will have annotated with your component annotations and so on, which will be processed by GSR269 processor to provide to generate classes, Java classes which contain runtime type information. All that will be compiled by the GWT compiler into JS files, and also because you have the backend in the same project, you have also the Java compiler outputting standard bytecode class files for your backend. Runtime-wise, as I said, I choose Spring Boot, but it's not important. I could have chosen any other backend, even a PHP one, if you want to suffer a bit. So you have the Spring Boot runtime, which loads your class, your classes, and provides REST web services, really classical thing. And it will also serve your static files. So the static files are the Angular2 runtime, which is JavaScript file, and the JavaScript files produced by the GWT compiler. And so the browser will load your files and make AJAX calls to your server. Nothing crazy here. And for live reload during development, you will use a super dev mode, which will provide source maps to the navigator, the browser, sorry, so that you can debug your application by seeing the Java code in the development tools of your browser. Okay, so that's cool. Let's implement that. Try it. Okay, there are problems. So what are those problems? First problem is that Angular2 is made by using the ECMAScript 7 modules, meaning it can load files on the fly. But it's not, GWT is not ready for that. Maybe Jackal will be able to handle that, but GWT doesn't comply with this ECMAScript 7 modules. So you cannot use the Angular runtime by just npm installing it and serving it from Spring. You have to generate a bundle. So that's what I did, and I did put all the Angular modules inside this bundle, but nothing prevents you to make, if you don't need, for example, in Angular, you have a form module to handle forms. If you don't need this module, then you could generate a bundle without this module to reduce the size of the JavaScript bundle of Angular. So that's not anymore a problem. There was a tricky problem. Angular, when it loads your component, it does a few checks. on the instance you provide to it, and mainly it uses this instance of operator to check that the instance you give it are really components. But with super dev mode, so when you are developing, the code is loaded into a frame of your page, so it breaks the instance of operator. So so few places needed to be patched in the Angular2 code, and maybe it can make you afraid, but this is only needed for the super dev mode to work. When you release your application, you could use the normal Angular2 bundle without modifying any source. Since I made some patches to the Angular2, then I need to build it. And build it on, as you see, I use Windows. It's not quite easy to build that Angular on Windows. So, of course, you can use Docker to build it, to have your a precise environment. And so each time a new version of Angular comes, I just rebase my commits on the tip of the branch, and it's like less, approximately 1 hour of work to produce the next version for Angular to boot. Another problem was, what if I want to integrate, to mingle Angular2 components with Git widgets? And I thought it would be difficult, but in fact it was kind of straightforward. So you have in the Angular2 boot library a widget adapter panel, so that you can put legacy widgets in your Angular2 application, and you have also the possibility to do the other way around, meaning if you have a legacy Git application and you want to progressively modernize it, then you can, for some screens, screen by screen, you can add Angular2 components into your Git application. So it's providing a two-way migration path. You can do both. Another problem is the testing of your application. So about unit testing, I didn't find yet a good solution. I had problem with the Git test suite, Git test case, because it uses HTML unit, which is not working well with Angular2 runtime. There's compatibility problem, and also the test case facility boots Jetty. But then I would like to do it with Spring Boot. So no real solution yet for the unit testing of, for example, Angular components that you have been written in Java. But integration tests, they work very well. I will show you a demo with you run a Maven test and it will instantiate your Chrome, do the clicking, check that the backend has modified the data and so on. So at least you can do integration test, which is securing your application. Okay, so after that I will do a demo, but let's just dig into what still is possible to add to this library. So, yeah, thank you, Manolo, for your presentation this morning, because then I thought, oh, maybe I can try to build a progressive web app in Java8 with Angular2. That would be cool. So maybe this afternoon will be ready. No. Yeah, generate UI code from model objects is it's not interesting. Why not also generate the services accessible from the services components in the client side from the interface of your JAX-RS services or Spring REST services? Why not? Good thing would be also to generate TypeScript definitions of your your Angular2 components, so that, for example, you can build some components in Java8, then you can use them in a very easy fashion in a TypeScript application. Why not? Next big thing is to run Angular in the national JavaScript virtual machine of the Java8. Why do that? To do server-side rendering. It's called Angular Universal, and it allows to pre-render the application, mostly for SEO problematics, and also to have an application that is usable most quickly by the user. Don't have to wait for the initialization of the Angular runtime. Why not try Angular to boot with also a native script? Why not? And for module loading, I think we don't have too many possibilities yet, so best is maybe to wait for Jackal. And the thing is that Angular's got an ahead of time compiler which tree-shakes your application. So it's doing optimization, so it would be interesting to have both Jackal, Clojure, and the Angular compiler, both of three of them doing optimizations on your code. Maybe try that. So, I think JavaScript and the Java communities, they need to exchange, they need to talk to each other, like like JS interop, but humanly speaking. For example, like in Java is 20 years old, so there are a lot of experience from Java. Could inspire JavaScript developers, and also Java, we are kind of slow to make new things and so on. So maybe the dynamism of the JavaScript ecosystem can also inspire us a bit. And I found an example of that. So Webpack is the new hype bundler for web applications. And what's funny is that it provides code splitting. And when you dig into that, because it's really called code splitting, you see the author of Webpack saying, code splitting, I didn't invent the ID, I found the ID from Git. So, yeah, it need to exchange between the two communities so we can do better things. The use cases of these things is, of course, to build a full Java applications, whether they be small or big. Maybe to also implement some parts of your application in Java, some parts in TypeScript, and so on. And also that would fit well in those scaffolding tools like JBoss Forge and JHipster. Maybe more JBoss Forge to begin with. So like you create an entity, it creates your view for that entity, your editor, your CRUD UI. So as you will see in the demo, the workflow is really comfortable. The bootstrapping of the application is really also simple. In fact, it's weirdly, it's way more simple than to bootstrap an Angular to boot application than to bootstrap an Angular TypeScript application. It's just one dependency you add in your POM file and you're done. Whether if you go to the documentation of Angular2, you see it's a bit complex. The fact that we don't use the user module of Git, in fact no widgets, it makes the compilation go way faster. So it's like you're using a kind of a new Git that you didn't know before. You will see. But still, you benefit from Git compiler. That you have a very, it's a great compiler. You have very cool optimizations. The generated JavaScript is really small and so on. It's easy to try. It's just there is an archetype giving you a working application. So please try it if you want to. So you have to create your application from the archetype. Then you do a Maven clean install, which produces a fat jar, an executable fat jar. You just have to launch it, and you have your application ready on localhost 8080. And if you want to develop, then you have to launch the live reload from Spring Boot for your server classes, and the super dev mode to have the live reload of your code, recompilation, incremental compilation on the client side. So let's try a little demo. So this is a simple application I made with, so I have, here is the Spring Boot Maven plugin running, and here is the Git super dev mode running. It was, I launched them before the talk so that it works already. Okay, and this one, it's really a little, very little demo application, which is written in so with Angular2 boot and uses materialize CSS as a library for the layout. So it's a classical one. There is a list of memos. Basically, it's a CRUD, so I can see the detail. So this is a sample memo. It was made for the wonderful GridCon conference. If I want to edit it, then, and so all this is taken. All this is how do you say? Managed by the Angular runtime, but programmed in Java8, as you will see. So, for example, there is this validation thing. It happens in the Angular runtime. You see, disable my button here. So I will say, okay, save, and I go back to the memo list. As you can see, the tokens in the restore is taken care of. Okay, so I can do like this. So how does the code look like? Oh no, sorry, I didn't add one. So it's I save and go back, and it works. And so the code is like this. So how many time? 5 minutes? 7? Okay. So what can I show you? All those demos are on GitHub, so you can go back to them. The idea is, for example, yeah, I will add some code here, and it will be okay. So here is the application component. It's the top. It's the root component of the application. It's basically inserting the router outlet, which will handle the history of the browser and inject the component which corresponds to this URL. Okay? But here I will just add some more markup to that. So what I will add is, for example, I will want to interpolate like title field. This title field, when you use this syntax, it means I want to show the value of the title field of my component. So I need to add a title field, okay? So maybe I will initialize with hello. So when you reload that, okay, it's here the hello, huh? I will put it happy. Here. Oh, sorry. So, yeah, it's here. Okay? So, what did Angular do is it will read my field and generate the accordingly it will generate my case. And you have what is called pipes in Angular, like this. So if you want to, you can transform the thing that is displayed. So it's really easy. And what's more is like I put this. I will put an input element, like type is a text. Let's put a BR also. And I want to data bind it to my field. So there is a syntax in Angular to do that. Oh, caps lock. So when you want to data bind a field, an input field into your component data, then you just have to do that. Okay? So if I reload, and if, so here is my input field, and it's data bound to the thing. So if I remove like this, it's about, it's kind of cool. I mean, you used to, if you want to do that with the widgets and so on, you have a few more lines of code to write, okay? So that's cool. What if I want to add a new component and make it communicate to with this one? I will make a component which will have a button and which will emit an event that the application component will catch. So I will add a new class. I can say my button component. So of course, since this component needs to be accessed by the Angular2 runtime, it needs to be exported to the JavaScript world, which is done by adding this annotation. And then I will say that this class represents a component. And when you have two things to mandatory add to your annotation when you want to be able to use it, it's the selector, as you would say. So I will use my button, for example. You will see what it's for, and then here I'm going to say there is a button, and I will say that, so it's the Angular syntax, the Angular2 syntax. When I want to catch the click button, the click event, sorry, so I need to put this into parentheses and say what I want to do when the button is clicked. So I will just call my onClick method, which I didn't write yet, so I'm going to do that. Okay. And here I want to output an event so that my parent component is aware of. So for that, I need to use this output. So you don't have no choice. You need to use this event emitter. It's how it works in Angular. You output some things to the parent component through events. And I will output events of type strings. And I will call that my output, for example. So when the user clicks on the button here, what I will do is simply to output, let's say, something like this. I think there's no space. Huh? Okay. So I created my component, and then I need to reference it in the Angular, the application Angular module. So if you go to the documentation, you will see that. Then I'm able to use my component through is selector inside all the application. And here I'm going to add a component my button here. So if I refresh normally, there is this button, okay, but it outputs no event. So, I mean, it outputs event, but those are not catched by my application component. So what I will do is I will catch my output event, is the name, and when this event is catched, I will click, I will say on clicked, for example. And I will pass to this method the event value, which is a string we know because the button component out is typed with string. And there's a keyword for that in Angular2, so it's called it's like this. Event means you pass the event value. So then I need to provide the method. And on this one, I will just do title equals value. Okay. So now I refresh, and if I click here, you have everything updated automatically. So I think I'm running out of time. No? It's the end, huh? So I won't have too much more to demo here. I mean, I have a lot more to demo, but no time to demo. Just what I want to say is, first, thank you, and also, you have you have a very cool documentation. Okay, so you have everything needed to get started. The tutorial mimics the one from the official Angular2 tool. So if you already used it, then you won't be you will find it similar. There's a cookbook and so on. And on the GitHub, on the slides there is a link for samples with this thing. So thank you. Question is over.